Amazing, amazing. Welcome everyone to the Earlywork event tonight. I'm Alaha. I'm the Ops and Community Lead at Earlywork. Earlywork is super excited to have you here with us today, and we are on a mission to help everyone find a meaningful career. Thus, the purpose for tonight's event in how to break into data science careers. We fulfill our mission through three pillars. We use content. So if you see our newsletter, we put out a lot of tips and tricks on how to do that. We have a hiring platform where we connect people who want to be employed and people who want to employ others. And we have a free Slack community that you can join and stay in touch and meet other ambitious peers. For tonight, before we begin, I would love to know what brought you here today. Give us an emoji react. If thumbs up, if you're here to learn about data science careers, a rocket emoji if you're here to build a career in a startup, at a data science startup. Give us a heart if you're just here out of curiosity and want to learn. Share your reaction in the Zoom chat now. Sweet. We're seeing a heart from Daniel. Amazing. Lots of curious people out here. Amazing. Hi Daniel. Amazing. A lot of people are curious here. Perfect. Amazing. Thanks everyone for sharing. For tonight's guest, we have a very special panel. We have one of the biggest thought leaders in data science here to present us here today, and moderated by Samanvay, which we'll pass it on to as well. But before I do that, I would love for you guys to share your favorite part of tonight's event. Feel free to screenshot any part of the event or any insights that you take from us here today and tag us on social media. We love to see and love to be supported as much as we can. And now I'll pass it on to Samanvay to take over.
Great, thanks, Alahe. So welcome everyone to our event tonight. So I'll be moderating tonight, and we're thankful for today's speakers, so Peter, Jacky, and John. So before we get started with the question, I'd love to just get these guys to introduce themselves. So we'll do it the boring old-fashioned way. So we'll just go in the alphabetical order. So if I could get Jacky to start off and give a little bit of an intro.
Cool. My name is Jacky Ko, founder at Relevance AI. I guess what else do you want to know about me? But yeah, before this, headed up a machine learning team at an insurance company, and before that, was working as a data science consultant at EY as well. I studied actuarial studies and what's my second degree? Mathematics. So there's many things you could know about me, I guess. Yeah.
Great. John?
Awesome. So John Hawkins is my name. I am chief scientist at a company called Playground XYZ, which is one of the new sort of breed of ad tech companies. We actually recently been acquired by a company called GumGum. We do attention models, and I can talk more about that later. My pathway into data science was through academic research. So I kind of, a long time ago, got very interested in AI, and then started off because my girlfriend at the time was very interested in molecular biology. She sort of drew me into her world. So I ended up doing work on applying machine learning to biological sequences. So predicting how proteins moved around the cell and what their function was, that kind of thing. And then when I eventually spilled out of academia or industry, I sort of have had a bunch of the usual kind of data science careers, some advertising, some in sort of banking and finance, and then some in kind of startups and consulting style work. Thank you.
Great. Lots of relevant experience to talk about a bit later in the show. Peter?
Hey, I'm Peter. I'll start at the beginning. I did a mechatronic engineering degree, so that was kind of my technical background, I guess. And then I went and worked in ops at Uber. And then I worked as a data scientist at Uber. Then I went to Atlassian. Now I'm at a startup and I'm doing software engineering and data science stuff. So worn a lot of hats, done a lot of different things across that journey so far. But yeah, excited to be here.
Amazing. So I guess I'd love to start off with a very broad question, and I think this will be relevant for people looking to get into data science and having a career in data science. So I'd love to ask you guys what your thoughts are on the data science landscape in Australia and how it's changed in the last 5 years. So mainly from two perspectives. So firstly, we could talk a little bit about how you've seen the adoption of AI change in organizations. And secondly, how you've seen the demand for data science talent change in the last few years. Because I remember 5 years ago when I started, data science landscape was very different to what it is today. So maybe, John, you could start off with answers to that and keen to hear your thoughts.
Yeah, sure. So, I mean, it's changed a lot over kind of what, if we look back sort of 10 years ago when the phenomenon sort of began at a really large scale, where it was really just a panicked rush to monetize data and create new business models as quickly as possible. And it was really, projects started without a great deal of sort of direction. And data scientists were basically expected to be sort of generalized magicians who could turn data into value. It's a lot more differentiated now. So I would say that there's a lot more jobs where you're specifically looking for someone who's an expert in, say, computer vision, or someone who's an expert in sort of text modeling or text generation, or like far more differentiated. And there's probably, because there's so much more, so many more good products on the market, I would say, while there's still massive problems in terms of poorly thought out projects starting all the time, there's a lot better understanding, I would say, amongst management of what's sort of possible, perhaps. Maybe that's
amazing.
Maybe that's a bit too optimistic, but it's certainly better than it used to be.
Yeah, amazing. And in your current role, I would assume that you're hiring lots of data talent. So you mentioned that we're mainly looking for very specific roles in the industry. So when you're hiring, are you also, what are the positions that you're hiring most for? Is it more generalist or is there a specialist there?
Yeah, so I think one of the natural segmentations that's kind of happened is you'll see a lot more people talking about ML engineering roles, and often they're the ones that are focused on particular types of modeling. So for example, we've just recently been hiring for computer vision specialist ML engineers.
Yeah.
That might have been just a general data science role previously, but now because the field's so big and so specialized, you're almost getting better off getting someone who's just focused on that component. There's still, and so we'll hire for data scientists, but often it's in that sense, we're filtering for people who are much closer to the business interface. So it might be someone, it's like this is a kind of a role that, I mean, Jacky would know this very well, that actuaries slide very well into, because they're used to thinking about how businesses function in terms of kind of probabilistic or mathematical models. So it's a really nice kind of place for an actuary to slide in, whereas a software engineer can slide more effortlessly, perhaps, into being an ML engineer, if that makes sense.
Yeah, that makes a lot of sense. And I guess with that, I'll pass it on to Jacky to talk a little bit about what kind of roles are you hiring for and how you've seen the data science landscape change, because I think in your company, you're expanding quite rapidly and you have been for the past 2 years. So keen to hear your thoughts there.
Yeah, we're hiring for general data scientists, NLP engineers, and computer vision engineers. And one of probably the harder role is more machine learning platform engineers. So those are the 4 main roles for us that we're hiring for. The data scientist one, it's more of a generalistic one where they kind of, hit a bit of everything. Whereas then the NLP and computer vision and machine learning platform one is a bit more specific. In terms of how the kind of the data science career landscape has changed. Well, the first thing is 5 years ago, when I kind of first entered the industry, you could tell that the data scientist role was kind of given to everyone, whether you're a data analyst, data engineer, or you're just a software engineer who happen to know how to use Python and Pandas. They'll give you that data scientist role. But now it's become a lot more specific, and I think that speaks to kind of the maturity of the adoption, where you start seeing this more specialization. That means the Australian landscape for the career is learning that there is this need for these different kind of roles. I'm seeing even data science product managers come up, which interesting how that works as well. But yeah, like the more specialization of these kind of roles, to me, yeah, it means that people are starting to realize that, yeah, you do actually need a dedicated person for all these things.
Amazing. Great. Peter, what are your thoughts there? So you recently finished up, well, a couple of months now at Atlassian as a senior data scientist. So you were there for quite a while. So what are your thoughts there from a corporate data science perspective in your career so far?
I think the context that both Jacky and John have given is interesting, but it also I get that what you guys have said is coming from very like more like technical deep tech kind of backgrounds necessarily, because I would almost say that a lot of the stuff that I see is kind of the opposite in regard, is that as the data science industry has gotten bigger and bigger and bigger, yeah, we do have a lot of specialization, and we are starting to see people break out into these ML specific roles and these engineering, these platform jobs. But at the same time, like the family of what a data scientist is growing, and I think a lot of people are still just calling people a data scientist for anyone who does basic analytics to building very deep models. And I think that's still a very fair thing, because when I consider data science jobs and I look at people who are excellent data scientists, sure, you've got to have a technical attribute, but it's more the ability to tie, and John, you touched on this, the business context to the data, and actually be able to use data in a way that is relevant and effective for the business. Because you can sit there and you can build the best model with the best accuracy and great precision and great recall and all that kind of stuff. But if it's not easily implementable, it's not really valid, like maybe there's other business contexts that you're not taking into consideration, like legal ramifications or like support, or how you actually operationalize it, how you reach out to these people and all this kind of stuff. If you're not taking that into consideration, then you're an ineffective data scientist. So when I've been hiring for people in the past to data science kind of roles, yes, the technical aspect is really, really important, but for the type of roles and the work that I've been involved in, what I've been looking for more are the people who are excellent communicators, and on top of that, really able to understand the problem space and also work quickly. It's about like deconstructing problems and understanding how you break it into bite-sized pieces, as opposed to just being really good at ML, because there's a lot of ML now you can just do on the shelf. I think that's one of the least important pieces of the puzzle for at least a lot of the stuff that I've been involved in.
Yeah, totally agree with you. And so I think that brings me on to the next point. And an interesting point I want to kind of tease up there is what you say here is that there's only so much technical and kind of modeling work, and you're looking for communication skills and kind of engineering skills. So I'm keen to hear your thoughts, I guess, for the benefit of the audience that's looking to get into data science and ML. One of the things that I was kind of disillusioned with thinking and getting into data science was data science is all modeling. But when you put that into practice, what do you think is the balance of training models and tuning models versus the engineering effort plus the stakeholder management type work? So what are your thoughts there? Jacky, maybe if you want to highlight something there from your kind of corporate background earlier.
Yeah, speaking from more experience, the stakeholder management, the like tuning the model to actually overall, like when we think about, I guess, engineering in general, you're just trying to solve a problem. So really understanding what that problem is really crucial. And especially if you're like a kind of, in a data science team that is really early on, that they're still trying to figure out what exactly to use data science to solve, to understand what exactly are the problems and what kind of solution that would be able to, like, what is even the benefit of solving this problem? That's usually the core starting bit. But to also like touch upon as well, in terms of kind of what Peter said with the problem solving side, I find that actually pretty, fascinating, like thing to talk about, because if we look at, what the reason why some of these people who can do like almost like a bit of everything to really get you from A to Z really is kind of like the unicorn, I guess people say call it the unicorn data scientist, is because it's still it's still kind of, going through its growing pains. People are still figuring out what exactly do I actually use data science to solve. But if you look at some of the I can't speak for Atlassian, but like some of the really large tech companies, a lot of the data scientists become almost just like, it's very clear what their task is. If you're like a machine learning engineer, your task here is to make sure that this model is, as fast as possible, as robust as possible. Whereas if you're a machine learning engineer, maybe in a small company, then you become like, okay, your main job is to do this, but you also need to think about what exactly should we be building in terms of machine learning models, etc. So it's really interesting how we're actually getting to that stage where there is those two distinctions in terms of like whether it's a more engineering focused data scientist or a more problem solving data scientist. I think right now, in terms of where we're at as a data science industry in a whole, the problem solving data scientists are the ones that are most crucial, because it's still in the stage where a lot of big companies are like, so I know there's this whole thing called data science, but I'm not 100% sure what exactly are the problems to solve with it. And that really requires like the collaboration between the business people and the data scientists to solve together. I recently was talking with kind of the director of product at Home Depot, and he actually mentioned something really interesting, is that they before they had like really siloed kind of data science teams. So pretty much you go to this giant data science team and ask for kind of feature requests. What do I want to build in terms of like, oh, I have this problem, can you build a data science model for it? That was, and then they changed to a different model where they actually slotted in mini data science teams within each product team. And it was interesting to see how being able to slot them in and actually get them to really, really quickly pick up the domain knowledge of that specific product team, how that has actually made it so that they were able to ship features faster. They were able to essentially act faster. I think I diverted a bit, but I just wanted to bring
That's
that
all right.
up. So, yeah.
No, that's really useful. I think I'll pick on you next, John, because I feel like given your kind of diverse experience with starting from research and going into industry and kind of corporate and startup data science, I feel like you've done quite a lot of kind of model-centric data science as well as the engineering data science. So what are your thoughts on where that boundary is from where you convert from being just very model-centric to then focusing on engineering effort? And then after that, you can maybe also touch on a little bit on which problems is useful to solve using the AI, or which are the ones we should really stay away from.
Yeah, cool. So like, I guess just touching what Peter and Jacky said, I 100% align with Peter in the sense of like, if you think of it in a normative sense, what you think data science should be, my general preference is it should be people who are focused on understanding business processes and then applying techniques to solve those business processes. But if we're kind of like anthropologists and we look at data science as a study, actually descriptively, the term gets used for all kinds of roles. Like some people come in and there's really like a manager of a data science team who's just going to tell them exactly what to do and doesn't want them to think about business processes at all. So the one kind of, if you'll sort of forgive me for one little sort of side tip here, I think it's really important if you are pursuing a career in this space to be really clear on the kind of work that you want to do. And anytime you are being interviewed back and understand what your boss wants you to do. If they're going to ask you, if you're going to get the freedom to solve problems, or you're going to be told to produce this report or produce this model, and know yourself well enough to know, am I the kind of person, do I just love coding and I just want to implement things, or do I actually like understanding how businesses function, pulling them apart, quantifying them, and building solutions that solve those problems? Know who you are, interview back, and that's the path to happiness. So that's my job done. So
really asking the why of the business problems you're trying to solve, right?
Yeah. So that's my preference, is it should be that like Peter, the normative position should be, it's like problem solvers focused on business processes. So it requires it, and it's not suitable for everyone. In some sense, you have to be almost pathologically curious. You have to like business. You have to like care how businesses function, and not all technical people are like that. So if your passion is coding and ML, then there are other roles for you, because the data science pathway to success is often about loving how the business functions and wanting to improve it. So I think on that regard, that's my personal preference. I think there'll be a lot of leeway there. It's going to depend, in some industries where you can imagine that there will be one of the other sort of avenues of differentiation we're seeing is because we know that domain knowledge is so important, and having the mindset to sort of extract and map that domain knowledge so that you can apply data science skills to it is hard and time consuming. There is more and more data scientists who are specialized in certain kind of fields. You can think of it like banking is a great kind of analogy for this, because there's been people who've been credit risk analysts for eons, really. They specialize in that. They know how the regulation functions. They know how to write the reports, that kind of stuff. They know what's been tried previously. And the same thing's kind of happening across a lot of different applications. So there's a sense in which it's worthwhile choosing early on in your career the kinds of types of data and problems you might want to specialize in, because it's harder to change later on, if that makes sense. And then, sorry,
Amazing.
You wanted me to segue towards something towards the end, but I've forgotten what that was.
Yeah. So basically touching on what you just said with the business first type approach to solving a problem, very loosely, what kind of problems do you think AI should be used for, and what are the ones that we should really stay away from?
Yeah. So, I mean, the easy two definitions, the ones that we should focus on are things like, so data sets where it's simply not humanly possible to have a human solving the problem. Like, so fraud is a great example. Transactions are flowing into financial institutions. They're complex tabular data. Human beings can't look at spreadsheets and quickly decide which ones are fraudulent and which ones are not. So it's a perfect kind of use case, because human beings aren't great at it, and we don't have kind of the time constraints make it impossible for us. The other end of the spectrum is things that human beings are actually good at, but are sort of tedious, and there's like efficiency gains. So classic example is like document processing, looking at a document and pulling out the name and the birth date and the kind of the address of people. So so things where you know that it's possible to do it. You can build a sort of computer vision model that emulates what humans do, and you can gain efficiency that way. Those are the kind of two obvious categories of things to apply it to. Things to not apply it to, there's a few categories. The one is if you can easily, like, you'll see people apply ML to problems where if you sat down and thought about it enough, you could sort of explicitly name all of the cases in which you're trying to solve for and exactly what needs to be done. So business rules are the perfect solution to that problem. They're easier to implement and audit. And even though you could in principle perhaps do it with ML, it may be sort of fuzzy, and it's almost certainly computationally less efficient. And then there's a bunch of stuff typically where the cost of making mistakes is really, really high. Often it's not a great use case for machine learning or AI, because it's so hard to fine tune something to get that cost benefit trade-off right, that you're better off having a human being do it.
Yeah,
amazing.
I'll just add to that last part, because I think that's really, I got some useful experience or context there. But like ML, I think for the most part, it's actually more impressive if you can do something that someone would use ML for. You can do it without ML. I think that's the coolest thing. If someone has spent like years building or doing research and making this cool model, and then you can do it with a couple rules or heuristics, that's so much cooler. And like some of the examples I have, and like on your point of like the cost of getting it wrong. When I worked at Uber, I was working in the Uber safety team. So I was doing safety data science. So a lot of it was predictive analytics on like cases of sexual assault or assault or a whole plethora of different things. And when you're dealing with data like that, like if you're trying to do a model that predicts the likelihood of an assault happening on a trip, then you're talking about something that happens 1 in a million, 1 in 10 million kind of stuff. Like you don't have enough data to train a model, let alone train a good model. So you've got to be really creative about what you do. And then almost on the flip side, also we solved that problem surprisingly well with just basic rules, like a lot of work processing data, summarizing data, generalizing data, and looking at it, just doing stats, or in some case, just basic algebra, and then getting that data to a point where you can apply heuristics or fuzzy logic or that kind of stuff. Super cool, super effective. And then on the other side, when you're given very limited resources to actually apply stuff. So there was some other work I had to do where I had to determine whether a vehicle was a car, a motorbike, or a bicycle, looking at GPS data. GPS data, when you're sampling it 3 times a second for tens of millions of drivers across the world. That's an absolutely outrageous amount of data. And actually processing that with a machine learning model, although possible and probably would work really well, there's a lot of companies out there that do that kind of stuff, very expensive. So how do you then take such a outrageously large set of data and reduce that down to something that's more reasonable? And you'd be surprised, like we built phenomenally good models that literally just calculated the gradients of lines on like some summary metrics, or looked at the distribution and then got some metrics out that describe the shape of that distribution. And then suddenly we've got a really effective tool at determining whether or not a person is driving a car or on a bike or whatever. So it's just like, it doesn't have to be complicated all the time in data science. And I think if you can do something like that and you've got the problem solving ability to break problems down like that, that's really cool. That's really effective. Yeah, John.
Yeah, let me lower the hand. Yeah, well, that's awesome. Actually, that triggered a thought, Peter. One thing that that I wish I'd been doing earlier in my career that I try and do a lot now is actually like baseline. Like, so I used to always build baseline models, but they were often something like a mean response regressor or like a naive Bayes or something like that. But actually just having a quick brainstorm session and say, let's devise a simple formula that we think is what's the most baseline couple of formulas that might solve this problem, and then running those as your baseline. Actually, it's a fun exercise in thinking about the kind of the causality of the problem. And often it can give you something that's either pretty close to a good solution or a really good feature.
Amazing. So I guess the key takeaway is use deterministic stats before you really go out there and do some fancy ML models.
Yeah,
I think that's a great takeaway.
You should know the data like the back of your hand, and you should be able to look at a plot and be like, I know what that is, before you're getting into the specifics. Yeah,
totally. Amazing. So I think go on, Jacky.
I was just going to add one last thing, and to be honest, it's kind of touched upon, but I just want to iterate. Probably the most important thing from my perspective is like, what kind of AI, what kind of problems should AI be used for or not be used for? Is just asking the stakeholder, is this actually impactful if I create an AI for it? Or, well, I use the word, is it impactful if I create a model for it or not? Sometimes from your perspective, you'd be like, oh, it's so impactful for me to forecast this metric, but then you give it to a stakeholder and they're like, it's great that you can forecast this, but I don't have any use for this. So I would say, that's I would definitely iterate, like, just always constantly communicate, especially if you're that kind of like they're working in that kind of role, constantly communicate with stakeholders. Like, is this actually important to you? It's same with software engineering in general. It's like you could build like a highly scalable thing, and then it's just like to the stakeholders, like, is this important for it to be highly scalable? They're like, no. You know what? If it's like super slow, if it only runs on one machine, that's fine, because we're only using this on like a small data set, for example. So that's definitely one thing. If I were to take away anything back when I started, was that just making sure that it's actually important, because sometimes it might not be.
Amazing. But I think I find that with more experience, you'll also find clients that are like, I just want to use AI, because they want to go back to the board and say, I've used AI. And that's becoming more common now, because people know about AI. And you're like, actually, we're trying to solve a problem. Don't try to tell me how to solve it. That's our job, to figure out how to solve it. So that also happens. So that's something to be wary of. Cool. I'd love to now deep dive into careers and chat a little bit about general advice that you guys would have. So let's say two different. So let's say I'm a graduate from high school looking to get into uni, or I'm in uni looking to get into data science. What are the things that you would recommend studying to get into the field of data science? Because 5 years ago, there were no data science degrees. We'd all be engineers going into data science. So keen to hear your thoughts there. Maybe Jacky, we can start off with you first this time.
What to study? To be honest, it comes down to like what kind of data scientist you want to be. But in general, like, stats is in my opinion is a great degree, because a lot of the machine learning models, obviously you can just plug and play it, but when you understand how it actually works, understand the stats behind it, it really helps you get a better sense of when does it work, when does it not work. Like through stats, you can essentially know, even like the baseline models, know when to use like a linear regression versus like a decision tree. Just simple stuff like that really helps. The software engineer degree is really helpful as well, because data science in general, there's coding involved, and often some of the best data scientists I know, they come from they apply as much as possible in terms of the software engineering principle in their model development cycle as well. So like making sure that they understand Git, how to use Git properly, how to structure my code properly, whether to code it more in object-oriented fashion, etc. Those are all key things that software engineer will help. The other one, which is let's say, if you want to be just to give an example, if you want to be a data scientist that mainly works in, let's say, ecology, for example, then that domain speciality will help you get real far. Peter comes from a more ops background, and I'm sure that actually has helped him a lot in terms of when he's fitting the model to just get a sense check. Is this actually going to be useful? What specific variables should I consider? Often when you're actually looking at a data set and you don't really fully understand the data set, it becomes much harder to solve any problems around that data set. So yeah.
Amazing. What are your thoughts there, John? Peter, feel free to go ahead.
Okay. I was just gonna say, my approach to getting into data science is I reckon it is the easiest job to get into realistically. And I'll say that I'm trying to convince everyone that everyone can be a data scientist, and I think everyone. And I think that there are things, the way the tooling and the landscape is changing. I think that everyone should be learning SQL, and SQL is going to be the next Excel spreadsheet or the next Google Sheets or whatever. And I think that makes you an analyst, it makes you a data scientist, it makes you whatever. I think that any degree will work realistically, as long as you've got the deep curiosity. And this is something that John touched on before, the deep curiosity. And with that, if you're relatively technical and you're willing to pick stuff up and you're willing to learn and teach yourself certain things, then I think you can really get into the industry quite easily. And you can go the academic route. You can do all the relevant qualifications, get a great marks and all that kind of stuff, and then go straight into a data science role. Or you can teach yourself SQL, some basic Python or whatever, and then get a job as an analyst and get the experience of work on the job. I think that there's really any pathway that you can use to get into it. And, Jacky, you spoke about all the object-oriented stuff and the coding stuff. I'll be perfectly honest, it's probably been 2 years since I've trained a machine learning model for my actual job. I haven't had to do that for a long time. I've done it to practice in my own time because it's fun and it's useful, but I don't think you really need to stress about that too much to be a good data scientist. So obviously any degree that numbers involved is going to be useful. It's going to help. Stats is really important because you need to learn how to do A/B testing and confidence intervals and p-values and all that kind of crap. But realistically, it's all stuff you can teach yourself.
Great, valuable insights there. John, I think you're the classic archetype for the data scientist with a PhD. Keen to hear your thoughts on that spectrum of. Yeah,
it's a tough question because you tend to, your natural tendency is either you're reinforcing your own biases or a bit of grass is greener. So I look at data scientists who I've worked with who I look at their careers and think, oh, wow, look at all that great stuff they learned in their degree. So I look at actuaries and go, wow, it's amazing how they just learn to think about businesses in terms of insurance is an amazing industry, really, because the whole business is models. There's nothing else. It's just models all the way down. And then, I'm always interested in people with strong econometrics backgrounds because they're used to thinking about sort of causal modeling and how you do structure modeling. So if anyone, I don't know if anyone sort of watches the presentations of Susan Athey. She's an economist who worked at Google for a little while and got really interested in how you can think about, because economists are always thinking about what's going to happen when you change the world, which is by definition is what you don't have data about anymore. So it's thinking about sort of structural modeling and causal modeling, that kind of stuff. So I get interested in all of that stuff. All I can say is that I'll sort of reflect Peter a little bit here, that really you're going to need some quantitative knowledge, and you're going to have to discover pretty quickly if you really like that stuff. So if you don't, if once you learn about p-values and you read about the reproducibility crisis in science, and if that doesn't fascinate you and you want to talk to your friends about it, you're probably not going to be a data scientist. Like, you have to care about this stuff. So you learn about it and you have to care about it, and then study something quantitative, and then study something that gives you domain knowledge, like Jacky was saying, that you care about. Because passion and quantitative knowledge is what's going to carry you there.
Yeah, I wanted to add as well, like, one point, which is Peter mentioned, like, the software engineering stuff. It's not a necessity, to be honest. Like, whether it's statistical knowledge, whether it's domain expertise, or whether it's software engineering, if you're kind of like, it's not like you have to be good at all three of them. But I will say, like, if you happen to be good at any one of them really, really highly, like, it will definitely help you become a better data scientist in general. Just speaking more from experience, having good coding practices when it comes to models definitely will help when it comes to, like, especially when just actually adding to your whole, like, script that runs the model, etc. But yeah, is it a necessity? No, absolutely not. It, like, depending on the organization, that part might be completely handled by a different, like, by the software engineering team, and maybe they'll introduce their own practices into it. But just knowing where exactly, as you're developing that, which way do you want to head is really key. It's similar to software engineering in general. Do you want to be? It's kind of like, do you like front end versus back end versus complicated low level general assembly code, like assembly code or something like that. So yeah, I said general assembly code, but yeah, you get what I mean. So yeah.
Great. That makes a lot of sense. So, hot question then, where should you, once you've studied all the things you need to do, what type of organizations would you start off your career? So I'm thinking there's startups, there's large tech companies, there's corporates like banks and insurance. What are your thoughts on where somebody should start off their career to get the experience they need to thrive in data science? Peter, do you want to go first?
Sure. I think everyone's journey is different, and I think it really depends on the way you like to work. Like, for me, when I started, I joined Uber, which at the time was like 6-7 years ago now, was smaller than it is, still huge, but every team was kind of working independently of each other. It was like a little startup. It was a kind of a really fun little vibe. And for me, I'll be honest, I joined because I wanted to have beers on the company every Friday and have a good time and just hang out with other really young, smart people. So that was what I did, and I enjoyed it. And it seemed like the culture worked for me really well. And then I was like, well, I'm enjoying doing this work, so I guess I'm a data scientist now. And it kind of grew from there. So I think, like, at the end of the day, you shouldn't put too much pressure on yourself to go straight into a data science job. Do something that you find enjoyable and introduce data into it. And kind of, you don't even need to get a new job. It could be your current job. Just start putting your hand up, being like, oh, I think we can, if we look at XYZ data, we'll be able to do it. Start in spreadsheets, grow from there. Like, if you're already in the workforce, and just volunteer your time to take more stuff on, doing something that you're enjoying. Go like that. If you have a PhD, then go for find a cool tech company that wants your knowledge or wants your thesis and apply it there. Or, it depends on your background. I'm always like, do the job that makes you happy, and put yourself up for the responsibilities that you need to get where you want to be.
Great. So basically show some agency in creating your own role and just create your own path rather than kind of succumb to stereotypes.
Yeah. And there will be places where you can't do that. Obviously, not like, I'm speaking very optimistically here about every place letting you do that, but it's not an impossible route to take.
Great. What are your thoughts there, John?
Yeah, it's interesting. My general bias here is that what you want to do is develop that kind of core problem-solving, business-focused data science skill sets, it's easier to do in smaller companies than it is in big companies in general. Like there'll be exceptions to that rule, but it's just that startups in particular, you're expected to solve lots of problems and sort of get in and get stuff done. That being said, the benefits of big companies is that you'll be surrounded, you'll be exposed to sort of greater diversity of people with backgrounds and skill sets, so you can get exposed to a whole bunch of new techniques really, really, really quickly. And if you're lucky enough to go into a big company that is somewhat data driven already, then you can, like that, the opportunities will abound. But it is in some sense easier to get more problem focused in a small company, I would say, if I had to,
So really what you're saying is kind of value the autonomy you get early on in your career and the agency to learn very, very quickly.
I've flipped back and forth. So like, I certainly learn a lot in big companies.
Yeah.
But I know I personally, I'm happier in smaller companies because I like the autonomy.
Gotcha. Amazing. Jacky, you've done both of those things. You've worked in corporate and now you're doing your own startup. What do you think?
Yeah, no, that's it's a good question. To be honest, like without listing names, I don't want to list company names, but I will say, you don't want to get stuck in the in between kind of part where it's like the company is not small enough or it doesn't give you enough freedom to I will use this terminology, but hack, essentially be forced to kind of solve a problem really quickly, which forces you to pretty much go through the end-to-end process really quickly. And that's what startups do. They because you have to solve this problem really quickly, you're kind of almost like brute forcing it so that you can go from A to Z really quickly. Whereas there's the other spectrum where you're going into a very mature like data organization. They have all the different kinds of roles. There's a lot of experts you can learn from. Both of those spectrums will be able to, is a good starting point. Whether it's at, I will say on the left, the kind of hacking it all together from start to finish, that one's definitely going to be a lot harder for most people. I will say, especially if you're just graduating, depending on the kind of personality and depending on how much, self kind of discipline you have, you might not be able to kind of prosper in that role. You might be the kind of person that does want to learn more from examples. And definitely go to the tech companies that have those kind of large data science teams. But definitely don't get stuck in between where it's an organization that they don't really give you any autonomy to kind of hack A to Z, and there isn't really any experts to rely on, and it's slow moving because that just means it's going to be slow for you to kind of develop any of those skills. And I guess, and this is kind of where we can talk about a bit of the Australia versus the San Francisco one, like the American kind of data science part, where I think this is where data scientists in San Francisco that I've seen has really been able to get more of this luxury, is that they have kind of organizations that are a bit of both. They're still early on in a startup, but they have the experts who's had all that experience working with large data science teams, who knows what is like kind of the right kind of methodology, right kind of tools for this problem, but you still have the autonomy to go A to Z, with their guidance. So whereas in Australia, that is kind of a lot rarer than say America, for example. So either end of the spectrum, I would say, but definitely not the middle. And usually you can kind of tell when you feel like you're not really doing that much or not learning that much. As soon as you get that, highly encourage you to change roles.
Yeah. So you're basically saying once your learning is plateauing, just kind of look for new opportunities where you would be able to expand your skill set.
Exactly, because data science is, ever changing. Obviously, even with the solid traditional methods, you can kind of pass by, but it's like if you really want to be a really good data scientist and learning all the tools, then as soon as you think it's plateauing, that's the time to change.
Great. Amazing. So I think now I'll switch into audience questions, and this is really free for all. So feel free to take, answer whichever question well, answer in whatever order you feel like is good. So first question is, we've touched on a little bit for this one. So for software engineers, on a scale of 1 to 10, how important would you say a data science master's degree is to break into the field?
0.
Oh, free for all as in any one of us. Yeah.
Yeah, anybody can just go in.
If you're a software engineer, I don't think you need another master's degree to do it.
Yeah.
Yeah, 0. Maybe a 1 because it's helpful.
That's very generous.
Yeah, but yeah, it's not necessary. Like a lot of those things can be self-learned, and even then, there might be organizations that's willing to, teach you in that aspect, as opposed to going to get a degree for it.
Yeah,
it's certainly not needed. But like, I personally like the externally imposed discipline of someone else expecting me to hand in assignments. So that's why I like Coursera so much. So if you can get that from a master's degree, go for it.
Yeah. But do you think a master's degree is still relevant if, let's say, you're coming from a non-technical field and you're looking to switch into data science?
I think it depends on where you're coming from, right? Like if you're coming from an arts degree and you don't know what a confidence interval is, probably going to be useful. If you're coming from econometrics degree or background, sorry, probably not super important. If you're even like some finance people have enough basic math that they can do it. Like I would say that there are some certain hard skills that are required. SQL is probably one of them. If you can't get the data, how are you supposed to analyze the data? Beyond that, like bit of Python or R or some basic coding language, pandas. I think Jacky said that before, it's a big one. But like, again, all stuff you can teach yourself. I don't think you need to go spending thousands of dollars on another degree.
Yeah, but as well, if you find it difficult when trying to self-learn and you do need that guidance, then I would put that rating higher, just because I think not everyone will be able to just pick it up instantly. I'd say.
Yeah, 100%.
I mean, the other value is it's a signaling mechanism as well too. It says prospective employers, I am interested enough in this to spend time and money on it, and other people, at least some non-zero size group of people think that I'm competent.
Yeah, like it'll not hurt in any situation. It's not a bad thing.
Yeah.
I will say, and this is probably a hot take, and solely on me. If you have like a master of like maths degree, for me personally, I would put that as like an 8 or 9, just because I know how difficult like high level university maths is, and just for someone to be able to complete and have the perseverance to finish that is a good signal that they could probably do anything. But yeah.
Amazing. So next question is, what's the best way to learn about data science application roles in adjacent industry, i.e. manufacturing?
Could you repeat that again?
So what's the best way to learn about data science application roles in adjacent industries?
Such as manufacturing. Google search it. Honestly, just type in, and looking at some of those industries, like how are some top companies in those industries actually solving data science problems. And this is maybe a more of an extrovert kind of thing to do, but go on LinkedIn, and if you're interested in the mining industry, go on LinkedIn, see if there's a data scientist who's working in the mining industry, ask them what's it like, working there. So yeah.
I will say, I feel like with certain industries, if you're looking at that, it becomes a bit challenging, especially like old and kind of industries that are a bit grumpy and like to be stuck in their ways, like mining, manufacturing, that kind of stuff. They're probably not the fastest to react and to try new things. So you might be doing the research and seeing a bunch of people saying, we don't need data scientists, we do it the way we've always done. But every industry has its problems. There's always something that can be done better. And every time you see someone say we do it this way because it's the way it's always been done, there's a perfect opportunity for a nerd to come in and fix it. So that's what I would say.
Yeah, so building on what Jacky was saying before, I was going to jump in and actually say, yeah, this is something I like to do, is find people on LinkedIn who work in industries that I'm curious about. But I'd build on and say that one of the things I like to do is, if you ponder what you think the kind of core problems are in that industry, and when you ping them, just sort of say, look, I'm imagining that these are the kind of problems you have to solve, and maybe you face these kinds of issues. Is that what it's like? And often, hopefully you'll get it'll give you a sense of, how well your instincts for thinking about what problems are going to be like, how well they're developed, but also they're also more likely to respond because you're sort of demonstrating that you're actually thinking about their industry, and they'll come back and say, no, there's a few subtleties here and there, and so it actually becomes both a kind of a learning exercise for you as well as an exchange of information. Yeah,
great, cool. Before I quickly pass it on to Aleha, I'm sure some of the people in the audience would have lots of questions for you guys. So what's the best place for them to hit you up?
I'm in Earlywork. You can shoot me a message there, or LinkedIn, give me a phone call, take me for a beer.
There you go.
Yeah, LinkedIn, Earlywork. Probably not phone call, but yeah, take me for a beer as well. So.
Yeah, LinkedIn, easy one to catch me. Also, I have a website for a book I've just released as well. If you just Google "Getting Data Science Done," you'll find me, and then you can sort of just email me from there.
Amazing. Congrats. Thank you so much, Samanvay, for that amazing moderation. Really enjoyed listening in and taking notes, even as a non-technical person. I found it quite useful as an advice. Check out these people's websites. I'm sure they'll be hiring and looking for amazing talent like yours. Thank you everyone for your questions, and the speaking panel tonight, you know where to find them if you have any questions or anything. Have a great evening, and see you on Slack.